this. I said before, messages are actually structured. Just as when you want to write your letter, you put on your your address, your addressee and the addresser's address and the rest of all that. Subject, title, blah, 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 salutation and all of that. That is agreed way humans communicate using letter writing. We also have agreed way too in email and the rest. So also with data communication, when Ethernet users wants to communicate, they format the message in a frame format. Not just frame format, we have frame, packet, and segments anyway. But the basic one at data link layer is frame. Now there is a structure. Frame has a structure. If you don't call it frame, you can also call it PDU, Protocol Data Unit. Now the structure of frame is what you have on the screen right now. We have preamble, start frame delimiter. That's start frame delimiter, destination, MAC address, and all of that and all of that. Now, preamble, what it does is just on that particular field, it synchronizes the data. You also have to synchronize the data to be on the same timing or the same sequence or the same frequency. I don't understand. Just to be on, if you understand by to synchronize something, just as if you have two phones, you want to connect, you need to synchronize to be on the same kind of timing. So that is what this particular field does. We have also start frame delimiter. Start frame delimiter indicates that the next field is destination MAC address. I've explained what MAC address is. What I mean by destination MAC address is if you have a computer 1 sending message to computer 2. In this course or in this training, we refer this C1 sending as source, while the recipient is the destination. So the destination MAC address, this particular field takes destination MAC address. That means the sender will fill in the destination MAC address here on this table. That is why it always asks of the identity. It asks from the switch, asking who is so. So we've stated that one before. So what is it's actually asking is the MAC address so that it will fill its own ARP table. And when it sends it, when it fills its destination MAC address, it fills its own MAC address, which is the source. Now length type or field indicates this is where the sender or the recipient puts the protocol. It can be that it's using IP version 4 or IP version 6 or some other protocol. This is where they specify the protocol they are using. Now, this is the content of the information, the data itself. It can be video, it can be text, it can be voice, it can be anything. We now have also frame check sequence, Instead of the frame check sequence, it contains another field called cyclic. This is SRC, cyclic redundant check. It contains cyclic, that should be spelling cyclic redundancy or redundancy check. So instead of this CRC, the sender, that is the source, always puts a formula inside of this CRC and use that formula to run a calculation or do some mathematical calculation and also place the result of using that formula. So when the destination receives the frame, the destination will see use the same formula here to run a calculation to know whether it will get the same result that the source got. If the result tarries, the destination will accept the message. But if there is any discrepancy, it will reject it. So that is what happened in FCS and many more though. So, and all of that. Now, frame in its entirety is between this and this. Anything outside of this is not acceptable. So the maximum size of the frame in its entirety is between 64 bytes to 1518 bytes. And any frame, coming back to something about this, any frame that is less than 64 bytes, when I mean bytes, I mean this. Any frame that is less than 64 bytes is referred to as runts. Any frame that is bigger than this is referred to as giants. Now, anything outside of this range is rejected by the destination. But there's exception. The only time we can have a section is that if we have a switch here, for instance, we have a switch connected to another switch. Thank God. Then we have some systems connected. For instance, we have some systems connected. If someone here is on VLAN, for instance, 2, here is on VLAN 3. Maybe this one is on VLAN 2, this one on VLAN 3, VLAN 2, and VLAN 3. If someone from VLAN 2 is sending message to another person in VLAN 2, when he gets here, on this point, the switch will tag that frame. It will tag it with the VLAN ID. And the size of the tag is 4 bytes. So that is only time. It's only between here. It happens between here and here, because when it gets here, this switch, second switch, will on target. So that is only time having maximum of this is acceptable. Like in that case, if you add +4 to it, you now have 15, 2, 2. That's the only time you can have something more than that that is acceptable. And it occurs between switches. That is number one. Then secondly, coming to this place, MAC address. MAC address is 12, is about 12 alphanumericals. And it's 48 bits. Let me show you instance of what MAC address is. IPconf. Okay, let me share this with you. Now, if I want to get the MAC address of my system now, ipconfig/o. See that if you look at this place, you see that you have, I have a wireless adapter. See the physical address, and the physical address is this. So this is my MAC address. Physical address is always the MAC address. If you look at it, you discover that it is about 12 bits. Sorry, it's about 12 alphanumerical characters. The same goes with other adapters too. You can have more adapters. My tunnel adapter is the same. See this one, don't forget about this particular one. But this is my what do you call it? My MAC address. Okay. Now, back to where we were. MAC address. MAC address is 48 bits. 48 bits. And in conversion, four, we have four, what they call four neighbor. No, 4 bits is equals to one neighbor. Then 8 bits, 8 bits is equals to 1 byte. Now we look at this place now. This is 48 bits. If you want to convert it to bytes, divide it by 8. And when divided by 8, this is what we now have, 6 bytes. 6 bytes. And MAC address does not change, it's always unique. Now, let me get out my MAC address. Assume that my MAC address, of course, you know that it's about 12 alphanumerical character. Maybe you have something like CE, for instance, 1, 2, 3, 4, 5, A, B, 1, 2, 3, 4, 5. Maybe you now have 6 and 7. Assuming this is your MAC address, 12 of them are 48 bits. A MAC address, there is something we call OUI, Organizational Interface, OUI. I forgot. OUI takes 3 bytes from the MAC address. The 3 bytes is 3 times 8, that is 24, 24 bits. Here is 4, 4. So it takes 8 plus 8, 16. It takes this first one. So this first 6 characters belongs to OUI. Please just take your time to read up about this OUI. It's manufacturer's identity and all of that for that particular device, be it phone, system, PC, and all of that. Just take your time to go and read up about MAC address and OUI. But just what I just want to give you is just that OUI start counting from OUI takes 3 bytes, and that's the space. This is the space that OUI takes. So I thought about major thing I need to talk about. Data itself is not supposed to be anything more than this. It's always of this range. And frame in its entirety is this. You know why switch rejects garbled messages or corrupt messages? Because they are less than 64 bytes. Garbled messages are less than 64 bytes. So you should take note of that. So for now, this is what I need to talk about frame. Although frame, there is much more about frame. We have other things to frame. There is still IP address and port numbers inside here before the length type. We'll talk about that one later on when we get to that level. When we get to that level, I'll talk about more of that later on. Except you have any question. If you don't have any question, we'll continue. Is there any questions?
No, go ahead, continue, continue.
Okay. So